Hi, welcome to On Production. I'm very excited today to take you through the production that we're going to look at this time, which is going to be focused on the machine learning tools that we use both to identify the zone of interest, or basically the awesome pay lane that we've been talking about, the Doucette lane, and we're going to go through all the details of the machine learning associated with it. And so what you're seeing right now is the summary of this notebook I put together, an R Markdown book, where I use the R language and do the machine learning. And all of the graphs, everything you're about to see are completely interactive. And I'm going to take you through a high-level view of the analysis that was done in order to determine this. So let's dive into this and take a look. Okay, so first off, let's focus on collecting the data. And what we're looking at here, and this is a pretty good view of this, and we're going to look at all the wells that are in this study area. And I like this. This is Leaflet. It's a pretty good tool. And you can see, okay, get in there, that we can focus on the individual wells of this particular study. Now, there were 24 wells drilled in this area that were this enhanced completion view that was being done by the company Whiting at the time. And I went and identified those, found several of them that were all in the same geographical area, which is what you're seeing here. And as you can see, with a little bit of manipulation here of the graphs and the data, which is really cool, is that we can go through, we can move these things around, and we can also adjust and say, for example, hey, these are all the wells that are in there. These are the study wells. We can click on them. We can see what they're like. I like controls like these. These are really powerful. They're also self-contained. So once you build this kind of analysis, you can literally just take this HTML file and send it to anybody, and they can go through and review the analysis with you. And this is one of the power tools that I like, that I've been able to develop over the course of the years, and I think you're going to like them too. So let's dive in a little deeper on this. You can see all of the wells that we're looking at here, and they're all in a regular geographic area, and they're also in the top producing area up there in North Dakota. So now we went through all of these, and as we went through these, there were several of the wells that didn't meet the cut, and most of the reasons they didn't meet the cut is if they had an exit, where they exited the main zone. I have no way of knowing from the public data if they actually sealed off those areas, so I removed those, and several which the data just didn't look right, where either the file was incomplete, or when you look closely at the file, you found that, well, they basically cut and paste from another file, and it's not the data from that file. So we had to make sure we were very clean on this. Now, the next step in the process, we did cross-sectional analysis, and let me show you basically what that's all about by looking at these three wells here. Now, the reason I focus on this is these are literally what Whiting was using at the time. This is the middle Bakken area they looked at. They called them A, B, and C, and these are three interpretations. And what we did with these interpretations, and we did with all the files inside there, is that on each and every well, we determined where the wells were placed. We used a tremendous amount of additional data in addition to just the gamma data on this. We also used a bunch of proprietary tools that we developed that help us to know when and where we are. And those involved working with the survey data, the directional data, and a couple of other pieces that we've learned just from working these wells. But I personally drilled these three wells in this area, and that's why I can give you an idea of how they do their work and how they categorize where things are. So we have an A and a B and a C, and we have all of these different ones that were done. These three wells just show a perfect example of that. So we went through all of the wells in the study, and we focused on doing that, and this is where we found and put together all of this and broke it down into, lateral lengths, how much was in A or B and in C. Now, we also determined stage placement by zone based on the public data that we had available, and you can see here what we're looking at is cumulative 90-day production, and we're looking at the number of stages and how many of them were in each of the different zones and different pieces that we're going through, and also the number of stages that you can see that were in there. And now we run the analytics on this data. So we're going to do basic machine learning on this. And the first thing we're going to do as we look at this data, and let me get this a little cleaner here, okay, is we're going to analyze all of the correlation data as we go through it. And we're going to plot the correlations. Now, I love this plot. This is a great plot. And what you have to focus on here inside of a plot like this one is the main thing you want to focus on is the very top row. Okay, so what we have here is cumulative 90-day production. And you can see we have stages, volume, pounds of proppant, max treatment pressure, treatment rate, lateral length, and average stage length. And all of these are being compared to production at cumulative 90 days. So if we look through here, if you don't see the number, there's really no correlation there. And then over here, you actually see the correlation that's along here. So what we want to focus on is the top row. And if you notice here, you got a 0.5 for volume and a 0.6, and with only 1 star, meaning it's not very statistically significant. And when you look at them, there's sort of a positive trend on these. In fact, if you zoom in on that one, you can see there's a little bit of a trend. Anyway, it's not very good. But I put this in here to kind of help people understand why everybody just started using more proppant. Because basically, if you're looking at just completion data, the only thing you're going to be seeing that's going to correlate to production is, looks like if you do more proppant, you get more production. Unfortunately, when you zoom in on it, you begin to notice that it looks like you get to a certain point with the proppant and you just don't get any more production. Now we go through, we look at this, we can't find anything really of any high significance on here. And as we go through and we do a regression modeling on this and try to compare it to production, we can't get a statistically significant model that can predict anything, which is really sad. And because of that, we basically move on. And what we move on to is now we're looking at the actual footage and stage placement data in here. Now, if you notice, the plot gets a little bigger because we've added Zone A's footage and Zone B footage, Zone C footage, and then the stages, Zone A, B, and C. Now, what you begin to notice when you look at cumulative production, you notice that there's a Zone B footage and a Zone B stages that correlates massively to production and is statistically significant. And when we zoom in on that, as you can see here, as we zoom in on this on this plot, you can see there is definitely a positive trend as we go through looking at this production. And when we go into that and we model this and we begin to do machine learning and begin to compare it to production, we get a highly statistically significant p-value, and we get a very, very high correlation on there. Now, I do a little additional work in here. I like to do stepwise regression. I like to look at all the different pieces and see if we can find an even better model. But at the end of the day, the most important thing you want to do when you're looking at doing any kind of production or predicting or anything like that is you want to make sure that you follow the rules. Always, always follow the rules of data. You follow the rules, you're going to get the right answers. And you can trust those answers if you follow the rules. But you also, as we look at production modeling and we look at the way all of these different enhanced completion wells that they were working on worked with, basically it came out with what it called a practical production model. And that goes like this. It says, hey, once you realize that there is this Doucette layer, this Doucette layer shows you that the more you put in it, the more production that you get. So why would you complete anything that wasn't in it? And so when I call about practical production modeling, we got to focus on getting the maximum number of stages and the only layer that is producing for you. And when we run that kind of modeling, that allows us to create a wonderful way of predicting. But how do you predict? So this is really important. I like to go through this in detail. I needed to come up with a way, and I wanted to make a very mathematically sound way in order to predict to production. So what I started with is just looking at all the type curves of all those wells in the area. So in order to predict and create a production model based on a type curve, well, if we notice, it's pretty dense on the lower side here, and it kind of spreads out up here. That's pretty typical wherever you look. And if we use ARPs, and you got to understand whenever you're using ARPs, you got to remember it's an average. So averages are always going to be affected by swings and by large values, right? So as we look at this ARPS, I wanted to get a shape of a curve that I could trust. And so we built that curve, got that shape in there. And here is what we went with. Once we got that best curve in here, how would we predict up to this point? Well, remember, I chose cumulative 90-day production. Now, why did I pick that? Two reasons. One is it was normally distributed. And the second reason is it's pretty close to the material balance transfer point where the curve begins to change. So if we predict to that point and then shift the entire curve up, then we can create a production range and a production model of where production would be if we increase the number of stages that are in there. I like this approach, and when you look at it from a cumulative standpoint, we get this wonderful green band out of here. And so when we did this cumulative production, I focused on basically 85 to 100% in zone based on our production model. So now with this, we've got a shape of a curve. We can back up with data, and we have a process for shifting that up the way we wish to shift it. So let's go through. So we do that analysis. We've run this analysis. We put all this together. And the whole purpose of this entire document was to get to this very last stage, which is this part and parcel at the very end is this wonderful little tool that we created, which takes that green band and allows us to hand off what the production increases would be, and we can give it to our financial modeler so that he can go through and model what this production increase would be. And you got to love it when you create one of these tools, because the moment you create one of these interactive tools, you can either save it as a CSV file or copy it and paste it into whatever tool you want to use and whatever spreadsheet you want to use to get that data and to be able to use that data. These are the kind of tools that we put together. Now remember, this is a high-level view of this, but I hope it gives you some good deep dive info, because these are exciting things and these are power tools. And when you use these, look, let's get together. Let's do some major production changes together. And that's what we're looking to accomplish here. Thank you for watching.